Hi, this is Group 2 Reportings and welcome to this video. To this video, we are going to report about the electrical component. First, I'm going to report about the resistor and capacitor. What is resistor? A resistor is another basic component of the electrical circuit. It restricts and blocks the flow of electric current through a circuit. The resistance of a resistor is measured by the energy that is capable dissipating in the frequency response of RF circuit. It acts as a voltage divider for the circuit. When a resistor is connected to a circuit, it controls the flow of charge by absorbing the electrical charge and later dissipating it in form of heat. Two basic measurements related to resistor are resistance and power dissipate energy. A resistor can be classified as a fixed resistor in which the value of resistance offered is fixed and variable resistor, which offers adjustable resistor when connected to any circuit. The formula to calculated resistance is resistance equals to voltage divided by current. Is capacitor. A capacitor is basically a passive component of an electric circuit that has potential store energy in the form of an electrical reducing potential difference across its plate. Many varied sizes of capacitors are available, including very small used to resonance circuit to large capacitors used in power factor correction. Consists of two or more parallel metal plates which do not touch each other but are electrically spaced separately by air or by some other good like mica and plastic and other. This insulating layer between conductive plates is called dielectric. Because of the presence of insulating layer, DC currents cannot flow through the capacitor, and instead a voltage is developed around the plates in the form of an electric charge. On the other hand, when a capacitors are connected to the AC circuit, the current passes through the capacitor with little resistance. Basically makes the electric charge by making use external voltage. Capacitor can be classified as fixed capacitors, the ones whose capacitance shows the fixed value does not be adjust behavior, and the variable capacitors, the ones which shows adjustable behavior to circuit operation. The formula to find capacitance is capacitance equals to charge divided by voltage. Main differences between capacitor and resistor. Capacitor is used to keep the positive and negative charges separate, while a resistor is used to control the flow of current to other components of the circuit. Capacitor does not lead any power loss, while resistor does. Both the capacitor and resistor are important components of an electric circuit. Work to determine the behavior of the circuit and are connected through the conductive wires. They are still differently in many ways that can't be ignored. Examples of resistor symbol. Resistor NEMA system, attenuator, non-burnable resistor, non-reactive resistor, resistor, protective resistor, impedance, heating element, resistor with fixed socket, resistor with sockets of current. Examples of capacitor symbol. Fixed capacitor, variable capacitor symbol, trimmer capacitor symbol, differential capacitor symbol, timpa trimmer capacitor symbol, and And that's all what I got on this topic. Thank you for your listening and God bless.
What is diode? Let us know what is diode. Diode are used to protect circuits by limiting the voltage and to also transform AC into DC. Semiconductors like silicon and germanium are used to make the most of the diodes. Even though they transmit current in a single direction, the way with which they transmit differs. There are different kinds of diodes and each type has its own applications. This symbol represents a generic diode or a rectifier diode. It is an electronic component made of semiconductor that allow current flow in one direction and block it in reverse direction. Zener diode is a type of diode that allows the flow of current in forward direction as well as reverse direction, but when the reverse voltage reaches the breakdown voltage known as Zener voltage. This type of diode made from of a small junction between an n-type semiconductor and a metal. It has no p-n junction like normal diodes, due to which it has very low forward voltage drop and fast switching because there is no capacitive junction, p-n junction. It is a type of diode that operates as a tunnel diode in forward bias and Zener diode in reverse bias, but its tunneling effect and Zener breakdown voltage are much reduced. It is used in rectification of a small voltage signal, 0.1 to 0.6 voltage. This type of diode is made from heavily doped P and N semiconductor that works on the principle of the tunneling effect. Tunneling is the phenomenon of escaping electrons between the p-n junction due to heavy doping. Tunnel diode has a negative resistance region where the current decreases with increase in voltage, and they are operated in this region. It is a three-layer diode where P stands for P layer, I layer, and N layer. The I intrinsic semiconductor layer is placed between heavily doped P and an N-type semiconductor. The layer blocks high voltage and reverse bias. Due to poor reverse recovery time, they are not used in high-frequency applications. Lead light emitting diode is a type of p-n junction diode that emits light when configured in forward bias. It converts electrical energy into light energy, and the color of the light depends on the energy gap of the semiconductor. It is type of lead that has two different colors of leads connected in anti-parallel inside single package. It can emit two different colors depending on its polarity. Changing the direction of current activates the lead with another color. A photodiode converts light energy into electrical energy. When light hits the p-n junction, it creates an electron hole per which flows out as electrical current. This symbol represents a photodiode. A generic photodiode is designed to operate in only reverse bias. This type of photodiode operates in both directions. This type of photodiode is made from two diodes in a single package with one common terminal, i.e. cathode. Transient voltage suppression diode is type of diode that is used for suppressing high voltage spikes. It is used for protecting circuit in reverse bias, unidirectional TVS. Thermal diode, also known as Peter diode, is a type of diode whose thermal resistance is different in one direction than in the other direction, so it allows the heat flows in one direction leaving the other side color. Laser diode, just like lead, it converts electrical energy into light energy, but the light produced by laser diode produces coherent light, laser beam. It is used in optical communication, laser pointers, CD drives, and laser printer, etc. As the name suggests, these diodes are sensitive to magnetic field and can be used as magnetic field sensors. Step recovery diode or snap diode, which instantaneously blocks the current flow when its direction is reversed. This is because of the low doping of p-n junction. Varactor or varicap diode is a voltage-controlled capacitor that has a variable p-n junction capacitance. Its capacitance varies by changing the reverse voltage. 7-segment displays is made of 7 LEDs in specific pattern. It is used for displaying decimal numerals and English alphabets. However, it can be designed to display numerous characters. It is made of leads in 5x7 matrix pattern. That is why it is known as dot matrix display. It has 5 columns and 7 rows of dots, shapes, leads next to each other. It is used for displaying characters and shapes in digital devices. Silicon controlled rectifier or thyristor is a diode made from PNP junction. Silicon controlled rectifier is activated to conduct current if the forward voltage increases its forward breakdown voltage or through a positive gate pulse. It is a PNP diode just like silicon controlled rectifier, but it does not have any gate control input. It is only triggered by applying forward voltage higher than its breakdown voltage. It is also known as full wave rectifier. It is made up of 4 diodes that converts the AC signal into DC signal. The process of conversion from AC to DC is known as rectification. This type of reverse rectifier is made up of silicon controlled rectifier thyristors. The thyristor switching time can be controlled by its gate input. Thus, this rectifier output can vary by controlling its gate input. A 3-phase rectifier converts the 3-phase electrical signal into a DC rectified output. It is a modified form of full wave bridge rectifier where 2 pair of diodes converts each phase. What is transistor? The transistor is electronic equipment. It is made through a p-n type semiconductor. When a semiconductor is placed in the center between the same type of semiconductors, the arrangement is called transistors. We can say that a transistor is the combination of 2 diodes. It is a connection back-to-back. A transistor is a device that regulates current or voltage flow and acts as a button or gate for electronic signals. Transistors consist of 3 layers of a semiconductor device, each capable of moving a current. A semiconductor is a material such as germanium and silicon that conducts electricity in a semi-enthusiastic way. It's anywhere between a genuine conductor such as a copper and an insulator similar to the plastic wrapped rolling wires. Transistor symbol. A diagrammatic form of NPN and PNP transistor is exposed in circuit is a connection dome form is used. The arrow symbol defines the emitter current. In the NPN connection, we identify electrons flowing to the emitter. This means that the conservative current flows out of the emitter as indicated by the outgoing arrow. Equally, it can be seen that for the NPN connection, the conservative current flows into an emitter as exposed by the inward arrow in the figure. The transistor is one of the most useful and simple electronic components which change the whole world of electronics. Almost all electronic circuits are used transistors. Integrated circuits or ICs also not possible to make without transistor. In this article, we are going to discuss the main function of the transistor. A transistor is an active device having a minimum of 3 terminals. There are mainly 2 types of transistor are mostly used, BJT or bipolar junction transistor, FET or field effect transistor. BJT has 3 terminals named as collector, base, emitter. FET has 3 terminals named as source, gate, and drain. Both of them are used for different purposes, but the function of them almost the same. Transistor function. Don't confuse with the function provided by a transistor in the applications of the transistor, because a transistor can provide only 2 functions. Only those 2 functions we use for different purposes and different applications. The 2 functions provided by a transistor are switching, amplifying. So the 2 functions provided by a transistor are switching of electronic signals and amplifying electronic signals. Now let's go to understand those 2 functions. Transistor as a switch. Generally, in digital electronic circuits, transistor is used as an electrically operated solid-state switch. Transistor is used in both high-power and low-power switching applications. Using a low-power signal, we can control or switch the high-power signal by using a transistor. Here you can see a lead is connected with a DC supply in series with a bipolar junction transistor through the collector and emitter terminals. In normal conditions, the transistor acts as an open switch, so it does not allow the flow of current, hence the lead will not glow. To operate the transistor as a closed switch, we have to give a voltage across the base terminal of the transistor. You can see an LDR light-dependent resistor is connected with the base terminal, so when light is applied on the LDR, its resistance will decrease and it allows the flow of current to it. As it is, a voltage will be applied across the base terminal. Once the voltage is applied across the base terminal, the transistor will act as a closed switch and it allows the flow of current to it, so the lead will be glow. As the transistor is a solid-state device, no power loss occurs during switching action, and it provides also a very fast switching facility. Remember that mostly field effect transistors is used for the switching of the electronic or electrical signals, especially MOSFET. Metal oxide semiconductor field effect transistor because they provide very fast switching facility and very low electrical power loss.